And then B part they are saying, that's the mathematical one. Taking the vertical velocity gradient of wind near the ground is represented by the formula V is equal to ky square, where y is the height above the ground and k is a constant. Taking the path of sound rays as are like paths given by. So here in this problem, this term written here is actually y is equal to h sine pi x by s. So whatever is the source, the written equation is not correct. So this is the correct equation. Speed of sound is given as Vs. Calculate the distance s downwind from a sound source where the maximum enhancement of sound intensity occurs. So basically, if I see how the sound is propagating, y versus x. So this is how the sound is propagating in the form of this sine wave. And as you move above this, wind speed is given as ky square. So basically, if you see, you are going from a denser to a rarer medium. Going from, so speed is increasing, so we are going from, we are going from rarer to denser medium, as mu will be inversely proportional to v, speed of sound in that medium. As we know from ray optics, mu is something like c by v, so we are using the same fact. So now let's say the sound wave enters this point at some angle theta naught, and as this is the trajectory of the sound, so I know that here it is traveling horizontally, and at this point I can say that the speed is v of sound plus kh square, because that's the maximum distance of y using this equation. So that's Vs plus kh square. So now when I apply Snell's law, saying this is speed of sound, so 1 by Vs into sine theta naught is equal to 1 by Vs plus kh square times of sine 90. As we can see the angle with respect to vertical, that's sine 90. So from here I get this value, sine theta naught is equal to Vs upon Vs plus kh square. But this is not we are supposed to find out. We are supposed to find out the value of this s. So now, using the same law, the refraction is cos of pi x by s. Pi x by s. So this is the value of cos theta. So from here, if I find out what is sine theta value, so 1 by sine theta, that is cosecant theta, s pi x by s. So this is the value of cos theta. So from here, if I find out what is sine theta value, so 1 by sine theta, that is cosecant theta, is equal to root over of 1 plus cot square theta, 1 plus cot square theta cos square pi x by s. Now call it equation 2. Now where it is entering, that theta naught value is known already. So if I put at x is equal to 0, theta is theta naught, hence I can say 1 by sine theta naught is equal to 1 plus h square pi square by s square, and this value will be 1. And sine theta naught value I have, which is Vs upon Vs plus kh square, so I put it there. So that is Vs plus kh square upon Vs is equal to root over of 1 plus h square pi square by s square. Now we can square both sides to solve this. So Vs square plus k square h power 4 plus 2k square h square. 2k h square into Vs, a plus b whole square, and denominator we have Vs square, and here we have 1 plus h square pi square by s square. That gives me Vs square plus k square h power 4 plus 2k h square Vs is equal to Vs square plus s from here. So I write h square pi square Vs square upon s square is equal to, taking kh square common, we are left with kh square plus 2Vs. And now see h square, so hence s is equal to pi Vs upon under root of k times of kh square plus 2Vs. And this is the answer to this given problem. So basically this is related to the concept of ray optics, as the light travels from one medium to another. So those who are in class 11th right now, this is a difficult problem for solving right now, because without knowing the concept of variable refractive index, this is quite difficult to approach. Now from ray optics, mu is something like c by v. So we are using the same fact